SureVoid Products presents SureSite. This animated video shows an established neighborhood with mature trees, houses, and streets. In the midst of this development is a vacant piece of property. A developer purchased this parcel of land for the purpose of building custom homes and contracted a geotechnical firm to test the soil in order to determine the necessary type of foundations. The test results showed expansive soils, and so caissons were designed to support the vertical weight of the building. This cross-section shows drilled piers and rebar with the top of the concrete lower than the top of the ground. Note that the ground has actually formed the top of the pier. A trencher is commonly used along with hand labor for commercial constructions in order to dig the needed depths and widths for exterior and interior beams between the matrices of drilled piers. Residential construction often forms these trenches by hand excavation only. The efforts often give a variety of results that were not intended. Wood is used to form the outside perimeter of the structure and is positioned to the proper elevation. Overdigs resulting from a trencher should be bulkheaded, eliminating excessive concrete or expansive soils can lift. Polyethylene is placed over the entire area as a vapor barrier, preventing moisture contained in the soil from penetrating the porous concrete slab. Specific sizes and mounts of rebar are positioned in perimeter and interior beams. Many engineers include a wire mesh in their slab design, which is positioned at the bottom of the slab. This combination of wire mesh and rebar material is one of the many structural designs used in residential construction. Normally, several types of inspections occur before the concrete is poured. Post-tension cables are also a common design. After pouring and finishing the concrete slab, the concrete sets, cables are cut, and the completed slab is ready for construction. There is now a new housing development within an older established neighborhood. Notice the old neighborhood behind and the new one in front. Many states, especially Texas, can be hot, and very humid sunny days are the normal. There are also many days that it rains a lot. Then the sun comes out for a while and starts to dry the soil, and the water puddles that have accumulated begin to disappear. Day 2, the sun is blocked by the rain clouds, and it's a downpour again. The sun reappears, and the water puddles slowly disappear. More sun, more rain. More water absorbing deeper into the soil. More lake stupids build up between these houses. Take a close look at the cross-section of a house on piers and see what this moisture in expansive clay soils can do when there is no void space between the foundation and the soil. The rain comes down upon the roof and builds up between the houses. The water absorbs deep into the expansive clay below and migrates toward the house. Notice the yellow arrows indicating the soils that are expanding upward, breaking the concrete foundation, which is causing major cracks to the house. The moisture beneath the foundation continues to migrate toward the center of the house. You're sitting there in your favorite chair, and due to the expanding soil, you hear some cracking. And now you know you have structural house damage. Look at the damage to the slab around the perimeter and the interior of the slab due to the expanding soils. Don't let this happen. SureVoid Products manufactures products that are complete systems that protect and isolate structural foundations from expansive soils. One of the components of the wall void system is the arc void, which is a pre-manufactured product with radial vertically sealed edges that are placed around the piers as shown. Another manufactured product of the wall void system is trench void. It is a rectangular product in shape, 5 feet long with factory sealed ends, and easily placed between the arc voids. The arc voids are at either side of the piers, and the trench void is positioned in between them. The void material that formed the space is now softened from surrounding moisture, so the ground can now vertically expand without causing damage to the beams. The moisture continues to migrate toward the center of the house, expanding the clays under the slab. One might think that the house is protected until you hear another familiar crack. Damage, yes, but notice this illustration shows far less foundation damage than the previous one shown. We now introduce a component of the slab void system. It is a rectangular box called slab void that fits on top of these quadrants of dirt. The polyethylene vapor barrier is placed on top of the slab void boxes to eliminate the moisture from vertically penetrating through the porous concrete slab. SureCover board is shown being placed on top of the plastic, but more commonly it is placed directly on top of the void boxes, eliminating any damage to the surface of the carton forms. A closer look is showing the arc voids fitting around each pier that was formed from the ground. Trench voids should fit tightly between the arc voids, but abutted joints will always leave small gaps. Seam pads are corrugated pieces of paper that can be taped or easily positioned by using a hammer and nails as shown. These now covered spaces or gaps will not allow the concrete paste and silt to enter and prematurely soften the carton form interior that has been exposed by cutting the needed filler pieces. The SureVoid product is the next installation procedure. Once this underslab material is installed and fitted, vapor barrier should be carefully positioned as per the specifications. First, the trench void is installed, then the slab void, vapor barrier, and SureCover board. The bottom and top rebar is positioned, then the concrete beam and slab is monolithically poured, and that is how it is intended. What actually happens is that after the trench void and slab void are installed, the poly is not positioned to the full depth of the trench and is strong enough to not allow the needed coverage around the rebar at the bottom of the beam. A suggestion would be that after the carton forms are placed, the poly vapor barrier material could be cut and the loose ends can be attached to the side of the dirt with nails. Additional plastic can easily be added to the bottom and sides of the trench if needed. This procedure would give the necessary coverage around the supporting rebar in the beam. In this illustration, the cover board protects the plastic from puncture and the underlying void material from damage. Normally, the vapor barrier is placed on the top of the carton forms. The complete system of products will totally isolate all beams and slabs. All rebar material in beams and slabs should be positioned as per the engineered drawings. A variety of rebar chairs will space the rebar a specific and necessary distance away from the bottom of the beams and slab or the top of the void. Wire mesh is also used when specified by the structural engineer. This illustrated video shows the concrete being placed by the use of a concrete pump. This will give better results. You can now see the newly created void space protects the entire concrete slab from the uplifting soils. The supporting concrete beams are completely protected by the carton forms that once were strong. Over a period of time, they are softened by absorbing moisture contained in the underlying soil. The moisture in the soil eventually migrates underneath the entire slab, softening the void material, allowing the soil to vertically expand. So whatever the weather, your entire structural foundation is totally isolated from the expanding soils beneath your home. It doesn't matter if it rains like heck or how much moisture is in the clay soil. You can now truly see that pot at the end of the rainbow. Relax, your investment is correctly protected. You now can live happily ever after and watch the birds fly by. Each and every last one of them.